Welcome back to Tech Initializer. In the last lecture, we drew the blueprint and answered what is system design. Today, we are taking that blueprint into the real world. Today, we are going to learn scalability. We are going to take a system from 0 to 10 million users. Imagine this. You launch your app today. It's brilliant. You post it on social media and suddenly it goes viral. Notifications are blowing up your phone. 100 users, 1000 users, and then 10,000 users. You are popping the champagne. You think you have made it. But then the tweet starts coming in. The app is slow. I can't log in. 503 server error. Suddenly the champagne stops. You check your logs and you realize the hard truth. Success is the leading cause of failure. What worked for 1000 users has just crumbled under the weight of 100,000. First, let's clear up a massive misconception. Scalability is not performance. Performance is about speed. If I click a button, it responds in 50 milliseconds. That is performance. Scalability is toughness. If 10,000 people click that button at the exact same time, does it still respond in 50 milliseconds or does the server catch fire? Scalability is the ability to handle more load by adding more resources without having to rewrite your entire code. You cannot fix what you do not measure. Before we buy servers, we need to look at the dashboard. We look at 6 vital signs. So first is requests per second. This is called the heartbeat. How many times are people knocking on your door every second? Second is concurrent users. This is the crowd inside the store right now, a live connection. Third is data volume, the weight. How many terabytes are you carrying? Number 4 will be throughput, the pipe size. How many gigabytes of data are flowing through your cables per second? Next is queries per second, the brain power. How hard is your database working to find answers? And finally, the last one is latency. It is called the reflex. When traffic doubles, does your speed stay the same? If latency goes up, when traffic goes up, you are not scalable. So we have the metrics. The alarm is ringing. How do we fix it? Now we have two paths. Path 1, vertical scaling or scaling up. This is the rich man's solution. You have a server with 8 GB of RAM. It's struggling. So you swipe your credit card and buy a monster server with 128 GB of RAM. So what's the good news? It's easy. No code changes. And what's the bad news? It has a ceiling. There is a limit to how big a single computer can be. And if that one supercomputer crashes, your entire business vanishes. Path 2. It's called horizontal scaling or scaling out. This is the Google way, the Netflix way. Instead of one supercomputer, you hire an army of cheap small computers. You put a load balancer in front of them. It acts like a traffic cop, waving cars into different lanes. If you need more power, you just add more cheap servers. Infinite growth. But wait, there is a trap here. For horizontal scaling to work, your app must be stateless. Imagine you are talking to a bank teller, which is server 1. You give them your ID. Next time, you go to a different teller, which is server 2. If your system is stateful, server 2 says, I don't know you. Show me your ID again. That is a very bad user experience. In a stateless system, we put your ID in a shared locker like Redis. Now it doesn't matter which teller you talk to. They all look in the locker, they see who you are, and they serve you. So rule number 1 of scalability, move the memory out of the app server. Now we know if we need to scale horizontally, we need to be stateless. But now we face the boss fight, the hardest component to scale in any system, the database. You can't just spin up 100 databases like you do with app servers. Data has gravity, state is heavy. To conquer the database, we use 2 specific weapons. You need to understand these before we continue our journey. Weapon number 1, it's read replicas. 80% of your traffic is reading data, only 20% is writing it. Think about Twitter. You scroll and read 100 tweets for every one tweet you actually post. If we send all the traffic to one database, it chokes. So we use a master-slave architecture. We have one master database. This is the only place you are allowed to write data, which is also called as a primary database. Then the master copies the data to several read replicas. When a user wants to view their profile, they ask a replica. When they want to update their profile, they tell the master. This relieves the pressure immediately. But there is a catch. It's called eventual consistency. It takes a few milliseconds for the primary to copy data to the replica. So if you post a tweet and immediately refreshes the page, it might not be there for 100 milliseconds. That is the price we have to pay for scale. Weapon number 2 is sharding. Read replicas help with reading. But what if you have so many writes that a single primary server can't handle it? Or what if you have 50 terabytes of data that won't fit on one hard drive? This is where we use the nuclear option, which is called sharding. Sharding means taking your logical database and slicing it into physical pieces. Imagine a library. Instead of putting all the books in one room, we put authors A through M on the first floor, shard 1, and authors N through Z on the second floor, which is shard 2. To find a book, you need a partition key, in this case, the author's name. This gives you infinite storage, but be warned, it is complex. You can no longer do simple joins across tables if they live on different servers. Do not shard until you absolutely have to. Now, let's tell a story, the story of application X. Let's watch how AppX evolved from a garage project to a Silicon Valley giant. Stage 1, the garage, 0 to 1000 users. So we have one server, the app and database lives together. It's simple and it's cheap. Now the problem, the app starts eating all the CPU and the database chokes. Now we move to stage 2. We split them up. One server for the app and one server for the database. Now stage 3 is for 100,000 users. So the database is sweating. Every time someone loads their profile, the database has to search for it. The fix? We add a cache. Think of the cache as a cheat sheet. We write the answers on the cheat sheet. Now 90% of requests never even touch the database. The system flies. Now stage 4, where the users grow from 100,000 to 500,000 users. Now the app server is the bottleneck. It can't handle the connections. So the fix, we go horizontal. We add a load balancer and spin up 10 servers. Because we are stateless, we can scale this to 100 servers if we want. Now the scale increases to 2 million users. The database is in trouble again. It's too busy. But we notice something. People read data much more than they write it. You look at 100 tweets for every one you write. The fix, read replicas. We create copies of the database. All the writes go to the primary database. All the reads go to the replicas. We just multiplied our capacity by 5x. Now stage 6. The users grow from 2 million users to 10 million users. Now the data itself is too big. The master database is full, 50 terabytes. It's too slow. The fix, we choose the nuclear option, which is sharding. We break the database into pieces. Users A through M go to server 1, users N through Z go to server 2. This gives us infinite storage, but it makes the system incredibly complex to manage. Do not do this unless you are of Facebook size. So what did you learn from the journey of application X? Scalability is a ladder. You climb it one step at a time. Measure your metrics. Go stateless so you can scale out. Use caching to protect your database. And only shard when you absolutely have to. But there is one piece missing. A system can be scalable. But what happens if a cable gets cut? What happens if a data center loses power? A scalable system that is offline is useless. That is why in the next video, we are going to talk about availability and reliability, how to design systems that never dies. This has been Tech Initializer. If you want to master system design, hit that subscribe button, ring the bell, and I will see you in the next session. Thank you.